Okay, good day and welcome to our lesson 12. So, lesson 12 is graphical illustration. I believe this is our last topic on chapter 2, which I'll just quickly confirm from the textbook. So, based on this lesson, so yes, this is the second last topic. So under this topic, we're just gonna be discussing illustration, graphical illustration, which normally works with data being collected, which at a later stage, we're gonna talk about how data is being collected, how do you analyze data, how do you perform uh, data sampling. So for this current lesson, it's a bit ahead of what we are supposed to have covered already. So it's going to be more of graphical illustration. So meaning that by the time we're done covering the way of collecting data, analyzing, posing questions, kind of those process, you'll then already know how to actually get to draft graphical illustration using your data collected and which type of graphical illustration will be the best. So this lesson is all about graphical illustration. So we've got different types of charts that are going to be covered in this lesson. So we will start from page 145 to 153, and some of the information or videos that you need to watch are those listed below, which some of them will be explaining the bar graph, pie charts, histogram, stem, and leaf plot. But before we start with our lesson for today, I would just like us to start by reviewing what we covered last week, which is also some of the things that is highly important that you understand before we start with lesson 12. So I just made a small activity. So were you in last week, on Tuesday? Sorry, I mean,
No, sir.
did you manage to cover lesson 11?
I barely got to this part, sir.
Okay, so what we covered previously, we covered equations. Where under equation we covered the definition of equations and how equation gets to work and how do you identify that this is an equation, not an expression. So normal equation will always have an equal sign somewhere in between the two expression or the expression and the constant. And we also mentioned that we have got variable and coefficient within an equation. Sometimes an equation it can be put it in much simpler method like the one we covered in lesson 2 and 3 and 4, the accounting equation. So that's also form part of equation. So normally an equation, it is something that will be tested and found that every information that is presented within that equation from the left side to the right side to say that both the left side will equal the right side at the end. And then from an equation, we get to what we refer as a formula to say that once an equation have been tested and have been solved, and we have managed to identify that indeed the expression written in the left side is equal to the expression written on the right side. So that becomes what we refer as a formula. So a formula is something that has been tested and it becomes a fact and gets to be used often to actually identify or solve future problems. So if an equation gets to be used often and or gets to be used to actually identify or solve future problems, therefore that equation becomes a formula. And from there, we then talked about two types of element within some of the equation where we've got dependent variable and independent variable. So mostly those we found them in linear equation, which is part of this activity, which is a revision of what we covered last week, where we talked about that dependent variable will be the one that depends on the other course of action being measured, and the independent will be the one that influence changes to the dependent variable. So we made an example where I used estimating future cost of the company to say that when you estimate future cost, we're going to be using a linear equation which we're already mostly familiar with, which is the y equals to mx plus c. So that will be the y equals to mx so plus c. So I'm using a mouse, so my handwriting won't be that good here. So it's going to be y equals to mx plus c. We say that this equation is not only used in just or only finance or only in mathematics, where we get to use it to draw a straight line. So normally we use this to predict future cost and in finance, and then in medical we also mentioned that it is used to predict future medical experiment, to say that if someone is sick, they can use this to predict if there is only one type of sickness that person is infected by, so they can actually get to determine the spread, how fast the virus is spreading, and also estimate the lifespan of the person, to say that you have got 20 days. In engineering, they also use to estimate cost as well. So also in media, you might also use this to estimate your cost within your finance activities within your company. So here I've just made some of the example to say that the broadcast cost, Eat a Lot company that has show called Eat a Lot on DDC Lifestyle channel on DSTV for the past 3 years has the following information. So normally when we're using the y equals to mx plus c, which is the linear equation, we have changed it to say that if we're gonna use this to estimate future cost, we need to relabel this based on cost. I would actually get to draft what we call an cost estimation equation, where y we say that it will represent the total cost that the company will incur, and then we said the m will represent the variable cost per unit, which will be multiplied by x, and then we said we're going to add as well the c will represent the fixed cost, since this will be the constant value. So meaning that no matter whatever changes in the number of units produced, or no matter the changes in the number of activity being performed, the fixed cost will remain constant, and our total cost will depend on the total variable cost plus the total fixed cost. So for us to get the total variable cost, we're going to say the number of activity performed multiplied by the variable cost per unit. And then this will give us the total variable cost. And then we add it with the fixed cost to give us the total cost for the company. So normally sometimes you find that when you're in a work environment, there are costs that you cannot classify either as a fixed cost or as a variable cost. Fixed costs are those costs that remain constant no matter what. For example, your rental, your business rental, if you are renting a business site or you are renting a warehouse. So those kind of stuff, they will remain constant even if you are using them for production of your shows. Even if you don't record any show production, you will still have to pay those rental fee. Your employees, you still have to pay them their salaries, especially those who are not involved in the acting, because your actors are going to be paid per scene. So meaning that the people, the cameraman, the administrators, those guys will have to be paid on a monthly basis, whether the show goes on or not recorded. They still have to be paid, but the actors will only be paid when they come to the scene. So meaning that the cost for the actors become what we refer as the variable cost. It will change by the number of time the actors comes in to play their role, meaning that if they come and we record 10 episodes, we are going to pay them based on the 10 episode recorded. And then again, the other guys, even if the show is not being recorded, but it's still gonna be recorded, those guys will still have to be paid. Your manager, your studio production manager, all of those guys. So their kind of cost, we refer them as a fixed cost. So in terms of variable cost, we could say that these are costs that changes based on the activity being performed. And the fixed cost will not change, will remain constant no matter whether activities are being performed. So meaning that when we calculate the total cost, even if there is no activity being performed, the total cost will equal to the fixed cost because the fixed cost will always be there. But the moment there is a variable cost, therefore activity being performed, therefore we're going to have a variable cost, which is the variable cost per unit, multiplied by the number of activity performed to give us the total variable cost, which we're going to add with the fixed cost. So all of these information, it gets to be used to estimate future cost. So this example, it's talking about a show to say that you run a company or a broadcasting division where the company is called Eat a Lot Company. You run a show called Eat a Lot on one of the channels that run on DSTV, which is a lifestyle channel. So the cost for the past 3 years have been identified to be as follows. To say that the on-air time, every time the show gets to be on air for the past years from 2020, which aired 1,250 times, and then the total cost was 72,500. On 2021, the show aired 1,300 times, and then the cost was 75,000. In 2022, it aired 1,175, and the total cost was 68,750. So we could go and say that this cost is a variable cost because it's changing as the activities are changing. So we could say that this is the cost because it's changing when the activity being changing. So meaning that if we identify this as a variable cost and we go and divide this amount with this number of activity being performed, and when we try to estimate future cost, and multiply it with a new number of activity, and we don't actually get a number that is close to this. So it just indicates that this cost could not be the variable cost. And if we try to look at the changes in the activities in terms of time it gets on air, it placed. So meaning that we see that the cost is changing, so it cannot be classified as a fixed cost. So therefore, this will classify as what we refer as a mixed cost, meaning that the total cost contain both the variable cost and the fixed cost. So for us to be able to estimate future cost, we need to know how much is the fixed cost. We also need to know how much is the variable cost. So to do so, we have identified that if there is a fixed cost included in both of these costs, therefore the changes within this cost will be caused by what we refer as the variable cost, because that's the only cost that will change based on the increase or decrease in the number of activity level. But the fixed cost that is within both these will remain the same. So that is the background in terms of lesson 11. So the equation is or the formula is total cost equals to variable cost per unit multiplied by the activity plus fixed cost. And under this scenario, we are required to create a linear equation to be used to calculate the cost to be incurred by the company in 2023. So if the show will air 1,200 times, so we are actually wanting to find the value of VC, which is the variable cost per unit, and the value of TFC, which is the value of fixed cost, to say that this is the cost that remain constant no matter the production or no matter the time this show get to be played or broadcasted on the channel. So we're still gonna incur this cost, which might also include your subscription fee. Whether you give them the episode or you don't give them the episode that is supposed to air that day, they will still charge you. So meaning that those kind of costs will fall within the fixed cost, and the variable cost will be the cost that you incur each and every time the show gets to appear, to say that okay, the show is going to appear, everything that we need for the show to run are those kind of costs that will incur per episode that is running on TV. So the transmitting cost, every type of cost that will be there, so those will fall within your variable cost. So under this activity, we have to find the VC and the FC, which will therefore give us the what we call the linear equation, which is for total cost. To say the total cost is equal to what variable cost per unit multiplied by the activity plus the fixed cost, which will be in rands as well. So the first step that I mentioned to identify during the previous lesson is that we're gonna use what we call the high and low method. So the high and low method is the method that says that the difference between the highest activities and the lowest activity will be the one that causes the change in the total cost price. So meaning that from our activity, we need to identify the activity types. What are the activity being performed? So the activity being performed is the number of time the show gets to be aired on TV. So on 2020 it was aired 1,250 times. This 2021 1,300 and 2022 1,175. Therefore, the total cost will still be our Y and this will be our X. So this become what we referred as the independent, and this one becomes what we referred as the dependent, meaning that the total cost normally depend on the number of airing time that we get to air our show. So this airing time becomes the independent, because even if uh, the cost will not be there if there is no airing time, so meaning that the total cost will just only be fixed. But for this cost to go up and down, it will be caused by the changes in the airing time, which is the air time. So meaning that the airtime is independent, as there is the one that have got the influence on the total cost. So therefore, to calculate the variable cost per unit, we're gonna you can first identify the 2 points, which is the highest airing time and the lowest airing time. So the highest airing time is 2021 and the lowest airing time is 2022. So meaning that the difference in this cost for 2021 and the difference in the cost for 2022, it's caused by the difference between this airing time. So this will get to give us what to call the variable cost per unit. So step one, identify the highest activity on airtime and the lowest activity on airtime. So the highest activity is 2021, the lowest activity is 2022. So step two is to identify the cost that is related to the lowest activity and the highest activity, which we identify to be 75,000 and the other to be 68,750. So step three is to calculate the variable cost per unit, which is M, or the VC. So to calculate that, we're going to calculate the difference in the cost, which we assume that this is the increase, which is the variable cost, and we're going to divide this by the difference in the activity level, which we are saying that it is the reason behind the increase of the cost. So the difference between the cost of 75,000 to 68,750, which is from the lowest activity, it's 1,300. So this 1,300 is the variable cost change from the two, and it is caused by the difference in the what we call 75,000 minus 68 is gonna be 6,250. 6,250, and then from the difference in the activity level will be 1,300 minus 1,775, so giving us 125 airing time. So meaning that from the lowest activity to the highest activity, the difference is 125 airing time, which caused a difference of 6,250. So meaning that per airing time we get to pay 50 rand per airtime, meaning that each and every time our show gets to play on the TV, we get to pay 50 rand. So if they play it 1,300 times, therefore we're gonna say 50 rand multiplied by 1,300 times. This will give us the total variable cost. So step four is to calculate the fixed cost, to say that if you already know, since from the information already given, we already have got one of these value, the total cost and the activity performed. So we can actually use this formula, which is total cost equals to VCX plus FC, meaning that we can reverse the formula to calculate the fixed cost, because we do have the value that we can use for activity level, we do have the value that we can use for total cost, and this time we already know our variable cost, which is 50 rand. So when we apply this, when we reverse this and make FC subject of the formula, so we're going to have FC being equals to TC minus VX, VXX, so meaning VCX. So meaning that our fixed cost will be equals to, we're going to pick the highest cost first, highest activity, which is 1,300. So we're going to have 75,000, which is the total cost, minus 50,000 multiplied by 1,300. So when we apply this using our calculator, so when we apply this using the calculator, so we're going to have 50,000 multiplied by 1,300. So that will be 65,000. So 65,000 represent the total variable cost for airing the show 1,300 times on the DSTV channel. So meaning that this is the variable cost. Because the show aired 1,300 times, we get to incur an extra additional cost of 65,000 for airing the show on DSTV. Then we also subtract this from the total cost of 75,000. Therefore, the total fixed cost become 10,000, which explain to say that even if the show doesn't get to be aired any time during the year, we're gonna still incur 10,000, which might be the subscription fee or based on the agreementation fee, to say that this is the cost that we're gonna pay to the channel, plus also to the production manager, because they will still be running the show on the background, recording and everything. So this will be the total cost for all of that. So meaning that this will be the cost we incur even without any airing of the show. So therefore the total cost equation will therefore be expressed as TC equals to 50 rand x plus 10,000. So meaning that each and every time we try to estimate future cost, we're just gonna put the number of airing time that we estimate to have this particular year, and then it will give us the total cost for that particular year, to say that if the show gets to be aired 2,000 times or 500 times this year, this is the total cost we're gonna incur for this year for the show being aired 5,000 times. And then again, to calculate this 10,000 here, I used the highest cost. But what I'm going to do now is that I want us to change this and use the lowest cost and see if we're still going to get 10,000. But based on the principle, since we use the 2 points to identify the variable cost, we're going to still get the 10,000. So meaning that if we replace this FC, TC and X by the value of the lowest activity, so we're gonna still get the 10,000 as our fixed cost. So meaning that here, instead of having 75,000, the lowest activity was 1,175, and lowest cost was 68,750, which is related to the lowest activity. So therefore, meaning that when we do this, we are going to say 50 multiplied by 1,175, which is the lowest activity. That will give us 58,750. So once we get 58,750, we're going to subtract it to the total cost of those activity to get the fixed cost, which is 68,750. So I'm going to just say minus 68,750. So meaning that you will see that we'll still get 10,000 as our fixed cost. So meaning that our equation is 100% correct. So meaning that we can use this to estimate future cost that will be related to us airing the show on the DSTV based on the number of times the shows gets to be aired. But this cost, because it's an estimation of future events, we know that estimating things for the future does not always go as planned. The cost might change because of number of factors that might influence it to change. So meaning that it will just give us an accurate or an approximate value to say that in the future we should expect to incur a certain value of this much. So based on our question, second question, it says calculate the cost to be incurred if the company plans to air the show for 1,200 times in 2023. So we are trying to estimate the cost for if the show gets to be aired 1,200 times. So if we check here from 1175 to 1,200 and the other one which is 1,250, the cost in between is 68,000. The cost is the lowest is 68,750, and the one above 1,200 times it's 1,250, which is 72,500. So meaning that when we estimate our cost, we expect it to fall in between these two costs because the airing time it's in between the two, so we don't expect it to below 68 or to be above 72,500. So let's try and look at how it was done. So we know that our fixed cost, our variable cost per unit is 50 multiplied by 1,200 time, so meaning that it's going to be 60,000. So once it's 60,000, 60,000 becomes our variable total variable cost, to say that if the show gets to be aired 1,200 times, we're going to incur additional cost of 60,000 based on the number of the show gets to be aired on TV. Then plus the fixed cost, which is 10,000. So this will give us 70,000. So the total fixed cost for the for the show being aired 1,200 times would be 70,000, which if we check here on our information, it's gonna be falling between 68,000 and 72,500. So it's lesser, it's more than 68 and lesser than 72. So meaning that our cost estimation equation is 100% accurate based so far. But in reality, the cost might actually get to change. So this is the solution behind it. So Mr. Sandisila, do you have got any question?
No, sir. It's just,
But do you understand?
yeah, it's straightforward.
All right. Thank you very much for the confirmation. So that is it that we covered last week. This is the most important area of what we covered last week, as well as some other aspect that I didn't mention on the previous lesson, which you will get to see them, especially in terms of solving an equation, to say that when you solve an equation, these are the principles that you need to follow, that there are 5 principles that you need to follow. And then the same principle, they also get to be applied uh, when you're changing the subject of the formula, like what we did here in terms of calculating fixed cost. So we changed the subject of the formula from TC to FC. So some of the principles or rules gets to be the same as the one of an equation. So solving an equation, since a formula and equation, it's actually one thing. So today's lesson, it's all about graphical illustration. So we'll be working with graphs. So when we're working with graphs, so in finance, I believe we work a lot with data than we work a lot with information. Everything that we have, all our investment, all our operation in finance or in media, we normally work a lot with data to actually understand how the business is running. Is the show being successful? Are we having enough viewers? In terms of the journals, are they being read a lot? If you are writing journal articles, if you are a journalist, so all of this plays a lot of number, and for you to be able sometimes to understand the pattern or the trend within those information, so you might actually have to illustrate them through a graph. So this lesson is all about that. So it says that by the end of the lesson, you should be able to understand different types of graphs of data, analyze data for presentation, understand one type of data of graphical illustration, which is the stem and leaf plot, the line graph, the pie charts, the bar graph, and histogram. But with the bar graph and histogram, this is also going to be part of our second of our lesson 13, if I'm not mistaken, where we're going to be talking more in terms of the difference between the two and when do you get to use a bar graph and when do you get to use the histogram and its advantage. So under this lesson, this is all that we are going to be covering, and the lesson outcome are that you should be able to create all of this graph by the end of the lesson, but I believe most of you guys are already familiar with it, so I believe there's nothing much in terms of this, but the explanation as well as some practical question that you will get when we get to perform lesson number 13. So graphical illustration. So these are the types of graphical illustration that one can actually get to work with. We've got the bar graph, histograph, frequency table, cycle graph, line graph, stem and leaf plot, line plot, and the box and whisker plot. So these are all types of graphs. So in terms of the introduction, we're going to start first by taking a look in terms of data. So you cannot have graphical illustration without data. So data is the most important things that you need to deal with before you present your information in graphs, tables, and chart. So we've got two types of data. We've got what we call discrete data and continuous data. So discrete data is one of those data that do not get to have mostly trends. So there is less trend because it's unpredictable. So it's when your data it's fully unpredictable, or the collection of this data it's not stable, so you cannot have a trend. But continuous data is the type of data where you can actually get to make a trend or pick up a trend. This is a data that gets to continue normally on a daily basis, and we can actually get to receive a sort of like a trend within this data. So it continually changes over time, and we are able to track down how is this being able to achieve this kind of data, to say that if this data we're measuring it in terms of time, how are we getting to utilize this time? So this is we are able to actually track. But discrete data, you can't actually be able to track how you're actually getting to collect this much data on a specific time, because most of this data it's what we call I'm just trying to find the right word for this kind of data, but it's getting to be lost in my head. So here it says that discrete data can only be certain of definite value. So you only get to be certain of definite value, but in terms of continuous data, it can take any value. So continuous data get to change often, but discrete data, it just only have to be certain about a specific thing. It says, for example, the number of customers that enter the bank to make a transaction on a different days of a week, or a number of ATM withdrawals made at a particular outlet for a different month or a particular year. So this one you can be certain that in between some of the months or some of the days, you do know that people will not have enough money, so less people actually get to use ATMs, less people get to come in the bank and perform transaction. But you do know that somewhere between the 26th to the 31st, this is the most busiest period. So a certain number of people, a certain number of value of people, you can be able to identify that these are the people that will come here. 95% of our clients will be using our services, all our services between this period. But in terms of continuous data, it says that there is an infinite number of possible value. Example, different times an athlete can complete a 100-meter race, to say that he can either complete it at 11.23 seconds, 10.13 seconds, 9.58 seconds. To say that, same if I was to use the same example as the bank, is to say that when it comes to between the days of the 25 to the 31st, the bank can expect what we call a continuous data in terms of recording of number of people that will be coming in. They will have an estimate based on their client, but they will not have an exact, because those numbers will be going up and down, left and right between those days. But they can be able to predict for that specific months, to be certain that at least this high percentage will be there. So the data that is going to be collected between the 26 and the 31, we could say this will be what we call continuous data. But for a particular month, we will say that this is a discrete data if we're looking at it in terms of a particular month, because they won't be certain in terms of, they will just only have an estimation. So here it says that the main difference between them is that the type of information they represent. Discrete data typically only shows information for a particular event, while continuous data often show a trends in data over time. So some of the difference between the discrete data and continuous data are that the values. So in terms of discrete data, it represents the exact figure you can count, such as the number of students in class. In contrast, continuous data often includes measurable value, representing a range of information, such as the extent of the difference between the shortest and the tallest student in class. And then in terms of types of data, discrete data continually have integers values, which is a whole number, but continuous data values often have fraction or decimal points. So these are the only difference between the types in terms of numbers. And the method, you can usually measure discrete data using simple methods such as a number line or a bar chart. But you may use more complex method to represent continuous data such as curve, histogram, um, stem and leaf plot, uh, the what we call this, the plot graph, where you get to just plot points. And then time intervals. So typically discrete data remain constant over a specific time interval, whereas continuous data has different values at various interval over time. So these are the difference between the discrete data and continuous data. So the more you collect information, you will get to see what type of information does this fall within. Is it continuous data information or discrete data information? If you are certain and you can actually get to identify the number to say that this number can actually be a negative, or the value of this data can go to a negative, so that counts it as a discrete data. But once the data can actually become a fraction, decimal, then you can also pick up that, okay, this is continuous data. And then the graphical illustration or types of graph illustration that we're going to focus on for this lesson is going to be the stem and leaf plot. Under the stem and leaf plot, the data are organized from least value to the greatest value. And then we also have got the line graph, where the line graph or the linear graph. So line graph and linear graph, it's one. So on our previous lesson, we did the linear equation. So the linear equation is what also referred as, can be used to draw what we call a line graph, because we can estimate our future cost or future information on a straight line basis, even though in reality information won't come out exactly, but it will give us an idea of what to expect in the future. And then the pie chart, also known as the circle graph, that shows the relationship of the parts of the whole. The circle is considered with 100% and the categories occupied is represented with that specific percentage, like 15%, 56%. And then we've got your bar graph, which is used to display category of data in compared, and it uses solid bars the same way as the histogram. It also uses solid bars, but the histograph says that it uses bar to represent the frequency of numerical data. So some of the difference between the bar and the histogram is that the other one shows the frequency, the other one shows the category of data. So meaning that if your data is presented in category, you cannot use a histogram, and if your data is represented as a frequency, you have to use the histogram. So that is all in terms of different types of graph. So Mr. Sandisile, what are your view in terms of the stem and leaf plot? Do you know any type of process, and what do you perform when you do the stem and leaf plot?
Nah, not really.
All right, let's just take a look at the stem and leaf plot. So, but before we do that, let's talk about the rules when you present your information graphically. So the first step is that your information have to have a suitable title. So to make sure that appropriate title is given to the graph, which indicates the subject of the presentation. So each and every graph that you're going to present, if you are presenting it for work purpose, it needs to be labeled before you even start to explain what the graph has to represent. Everyone have to have an idea of what you're going to present by the headline, and therefore you will give them a full brief in terms of what you're about to present and why the topic or why the heading. And then measuring unit, so your graph have to show measurement. What are you measuring your information by? Is it by ages? It is by usage? Um, is it by the number of people that get to use something, if it's a software, numbers of viewers, and numbers of likes? So it have to have a measurement. So your graph have to have a measurement to indicate what are you measuring against what. And then the proper scale to represent the data in accurate manner. So you need to choose a proper scale to say that the type of information you're measuring by, what type of scale are you using? Are you using, is your information or data collected in thousands, or is it collected in hundreds? So if it's collected in hundreds, therefore you will therefore get to actually get to apply um, the 100 scale to say 100, 200, 300. But then if it's collected or your data is highly or mostly in terms of thousands, therefore you might have to present the whole information in thousands. And then we also have got the index. So the index is the appropriate color, shades, line, design in the graph for better understanding, to show that okay, this is different information. You might have to use different index to say that this will be blue, this will be red. Red represent numbers of viewers, and then the blue underneath represent the people who like, and then the green people who don't like the show. So, and then we also have got the data source. So data source, you also need to include the source of information. Where did you get the information if necessary? And then also when presenting the data, you need to make sure that you keep it simple. Don't complicate the information on the graph. Make sure that your data is presentable, it's readable, even without your presentation. You presenting the data, you need to make sure that someone can read and then understand the information that you are trying to present or that you have presented to them through your presentation. Your work need to be neat. Choose the correct size of font color in such a way that the graph should be a visual aid for a presentation of information. So this is all the rules or some of the rules that or certain principles that you need to follow when presenting your information graphically. So the first part is the stem and leaf plot. So stem and leaf plot is actually get to use to estimate or to actually give us an indication to say that in terms of our data collection, these are numbers of people that are doing the following certain things, or this is the range of information. So it gives us a lot of information based on its presentation. So here it says that a stem and leaf plot is a way of presenting quantitative data in a graphical format diagram. So it doesn't have a diagram sort of like a bar chart, but it's sort of like column and rows. So normally you're going to have what we call a stem, and then later on you're going to have what we call a leaf. So a stem will be the base of the numbers that you have collected, and then a leaf will be representing the numbers that are there within that information provided. So here it says that the good thing about it is that it is from the diagram it is that from the diagram you can obtain original data, so no information is actually lost based on the presentation of a stem and leaf plot. So an example is based on the following information that is collected, to say that if the following information was collected, you can use a stem and leaf plot to actually get to plot all of this information, to say that you have got the values within the tenth, you have got the values, all of the values are within the tenth. So when you represent, meaning that your stem and leaf plot will represent the tenth by one digit, to say that 1 represent 10, 2 represent 20s, 3 represent 30s, 4 represent 40s. So when you write the leaf will be 21, 22, 23, just like that, based on the order of the information. So if you have got information like this, so what you're gonna do is that you're gonna have your 1 here, and then if there is values that are falling within the 10th, which are from 10, 11 to 19, so all of these value will be listed after under the leaf. So the most important information is that when you're performing a stem and leaf plot, your data will not be organized. So the best way for you to be able to do this is to organize your data from the smallest to the highest, and then you'll be able to identify your range to say that this is my range. So meaning that if we're to have this as the value of 10, so therefore when you put the leaf will only be the value that is from 10. So 10 plus what? So 15 is 10 plus 15. So we're going to have a leaf being 15, 5. And then 16, therefore we're going to have a leaf of 6. So when you get to read this, it's going to say 15, 16. Same applies to the second part. So since we're saying that the second stem will be 20, so we're going to represent it by 2. So meaning that the leaf will be the number of value within the 20th to the 30th. So meaning that it will be 21, 22, 23, any value that falls in within. So you also list them by what we call the order, based on the order of the information. So we've got 21 here, then you look for another value there, then you have got 23. So if it's repeating, you write it twice, so meaning that someone, when they read this information, they'll still be able to pick up that, okay, we've got 23 coming up twice, and we also have got 26 showing up twice within our data. And then we're gonna move to the 30. So you have got the value of 30, so you're gonna just put 0 to represent that, okay, this is 30. And then for 32, you guys gonna put 2, so therefore you're gonna represent that is 2. So at the end, you can still count to say that how many values of data was collected by counting the leaves only without counting the stem, to say that we've got 1, 2, 3. So on the stem 1, we've got 2 leaves. Stem 2, we've got 1, 2, 3, 4, 5. So that's 5 leaves. Stem 3, we've got 2 leaves. Stem 4, we've got 1 leaf. So that's 1 plus 2 plus 5 plus 2. So that's 10. So meaning that there are 10 numbers that have been collected, or there are 10 data collected. There are 10 information from our data that has been collected. So when you go ahead and count, you're going to still get the same number of data, to say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So you're still going to get the same value. So here it's also talking about the example that I just mentioned, to say that leaf 5 means 15. So when you see this 5 here, so this leaf 5 will be representing 15, and the 6 will be representing 16, and the 1 representing 21. So as long as you can identify the range of your information, is it in tenths, thousands, and then you'll be able to identify the stem that you actually want to use. So the stem have to be in classes, to say that if my information is 5, 10, 15, 20, 25, 30, so you can actually present it in terms of 0 to 5, 6 to 10 to 10 to 20, 30 to 40, just like that on your stem and leaf plot. So on our textbook, it's also presented in a different method, which will still lead you to the same principle that I just explained. So do you now get an idea, Mr. Sandisilo, of the stem and leaf plot?
Yes, sir. Okay, I do.
Right, and then we've got the line graph. So in terms of the line graph, this one is a much straightforward. So I believe this one you are more familiar with, isn't it?
Yes, sir, of course.
Yeah, so here it just says that the line graph is the most useful when presenting data of information that changes continuously over time. So meaning that if you are working with continuous data, it is best to present it in a line graph, because that data you will be able to see the trend of how that information gets to go up around. So here they have used an average of media consumption per person worldwide, to say that the red represent the TV, the other one, the blue, represent the internet, and the time each and every person spent on TV and the time compared spent on the internet, to say that An average person during the year 2009, one person used to spend 48 minutes on internet and 188 minutes on a TV. But as time goes on, you will see that the number of minutes we spend watching TV are decreasing, but the number of uh, minutes that we spend on internet are actually growing. So meaning that now more people are spending more time on the internet than the TV. So meaning that this data is showing data from 2009 up to 2016 based on consumption of social media or the TVs or media, which is TV and internet compared to against each other. So meaning that if we take a look at 2020, we'll notice that internet will be very high and TV will be very scarce. So that's why even DSTV have already introduced their streaming platform instead of you subscribing and having the TV with you, because they know that most people are spending more time on internet, so no one will want to sit in front of a TV only at home. So they will still want to stream. So that's why they opted as well for the streaming DSTV subscription. So here it says that a line graph, also known as a line plot, or a line chart, is a graph that uses line to connect individual data points. So once you connect the dots, you can therefore actually draw a line that connects all the dots, which will show an indication of how the graph is moving and from which point to which point. Then you can actually follow the trend from the continuous data to see that based on this trend, we can actually see that as time goes on, TV will actually get to have less time being spent on. So if we take a look at 2009, we could actually predict that somewhere around 2029, we might find that the opposite might be happening. So that will be like a gap of to say that by 2029 we could expect the gap to be the opposite from 2009 to 2029, to say that TV might be 48 and internet might be 18, because we are also moving to the fourth industrial. So meaning that things are actually changing very fast. So TV might actually lose its customer, because now some of the reason that the US is actually fighting with TikTok is because more people now have got freedom of speech on TikTok, and they are getting news no longer from the television or from the medias that they actually currently have, which they can actually get to manipulate. But because of TikTok, news are being presented there, so no one gets to wait for the news on the TV or on the newspaper. So meaning that for you to actually get to change the narrative of any media news, you actually have to use TikTok to publish that information first at first hand. Then people will actually get to see that information first. But because there are a lot of people out there and the user are actually so many, so it's now easier for you to grab information faster and receive information faster because of the social media app. So that's why some countries are saying that they are banning the activities within that app, because it's actually going to take a lot of information out. So that information or trend can be done through or be seen through the line graph by comparing the apps, to say that let's compare the usage of the apps and the type of information the apps actually have, to say that does it have more information on entertainment, news, and they will be able to see that the most important information that is being presented on the app, it's actually news, meaning that on our news side where we get to present news, where we can actually get to change, we will only have much less to actually get to give out, because most of the information will be already out. So that's another most useful thing to actually get to identify. So you can also use a line graph. And then we've got a pie chart. So in terms of a pie chart is a circular statistical graphical which is divided into slices to illustrate numerical proportion. So a pie chart, I will say that we are working on fractions, to say that if we have got a certain number of information, let's split it down based on the total number of information we received and see how much information we received from this, from all our source, and then what is being represented by what. So this is all that we use the chart for. So here it says that a chart Each arc of length is a proportional to the quantity it represents, to say that we're going to also get the total number of information received. If I was to use a practical example, I would say that we can use a pie chart to actually get to split the amount or the budget that we actually get to receive. If you receive an allowance from home, you can actually present it in a pie chart to say that from all the money that I received, 20% of this money goes to transportation, 40% goes to rental, 30% goes to food, and then if there are any remaining percentage, you will get to allocate them. But the most important thing is to say that the money that you receive or whatever you are trying to measure, it will be measured as 100%, and everything that is being removed from that portion, it will be measured as a percentage of that 100%. So your pie chart will always be measured as out of 100% instead of figures. So even though you show figures, but it will still be measured out of 100% or 1. So when we say 1, we're just saying 100 divided by 100, which is 1. So that's 100% in decimal, so it will just be 1. So it continued to say that a pie chart shows data at one point in time. So it is more of a snapshot. So meaning that you can only use a pie chart to represent information that you know that this information will only be useful for only this particular moment. So if you are to present information that will be tracked over time, so a pie chart will become irrelevant because you will want to see the trend of information, and a pie chart doesn't get to allow you to do that because it only shows you data of that only once of period. So meaning that if changes happen, it will only show you the current changes or the snapshot of that changes. So it won't show you what from what information changed from to what. So only a line chart could also show you that, with other type of graphical illustration could be able to show you that these are the changes, but the pie chart will not show you that. So it only shows once off information. So if you have collected information and you know that it's a once off, you can use a pie chart. But if you know that information, you're gonna need to track changes. Therefore, you cannot use what we call a pie chart. So pie charts, I will say that we normally use them for past information. So only when there is past information that have to be presented, because we will not look at the trend, so we can get to use a pie chart. But if you are doing future estimation and everything, if that future estimation is going to require a trend, so a pie chart can just only be used as an overview, but then you still need another chart to actually present the trend as time goes on, to say that we are still on track. This is what was there in the beginning, and this is what was there, this is what is available now. So it continues to say that to present data in a pie chart, you need to first calculate the total value of the entire data and calculate a percentage of each point, which is one data value, against the total value, to actually get to identify the percentage or the proportion or the portion of that data against the total data collected. Then you can be able to plot your graph. So here they've used example of favorite TV shows to say that if these were your favorite movies, you love four sci-fi movies, comedies, you have got four, action, you like five movies, romance, you like six, drama, you like one. So when we add all of these number of shows, it will be 4 plus 1, that will be 5, plus 6, that will be 11, plus 5, that will be 16, plus 4, that will be 20. So you have got a collection of 20 movies, and based on your collection, this is the result. 4 are comedy, 5 are action, sci-fi. Those are the type of movies that you have that you like. And therefore, when you present this information, it will be 4 out of 20 giving us 20%, 5 out of 20 giving us 25%, 6 out of 20 giving us 30%. So we could actually get to justify this by just saying 6 out of 20 and then multiply by 100. So it will be in percentage as 30%. So meaning that the value of romance movie equates to 30% of the movie collection that you have and like. So therefore, that's how you're gonna present that information within your pie chart. And then the bar graph. So any questions so far? on everything that we just covered?
No, sir.
No, that's good. So, but you do understand everything.
Yes, I do, sir.
So, how often do you use the graph?
Witchcraft, pie chart, stem leaf, witchcraft.
Any of those that I presented so far?
How often do I use them?
Yes, or how often do you come across them?
I rarely come across stem leaf and the two that we spoke about. I rarely come across them.
No, that's
Maybe I think based on bar graph and sorry, maybe a
yeah.
scattered plot I would see on a weather channel or something like that.
Oh,
Yeah,
yeah. So they use the scatter graph, which is also the scatter graph and the line are almost similar. Just that the scatter graph doesn't have the line,
yeah, yeah.
but it's just only the points. But you can still connect the dots and it becomes a line graph.
Yeah, exactly. Yes.
Yes. So and then in terms of the bar graph, so the bar graph, it says that here it's a chart or graph that present category data with rectangular bars with height or length and proportional to the values that they represent. So the bar graph can be plotted vertically or horizontally. So we've got horizontally and we've got vertically. So it can either be plotted any of the way. So it doesn't matter how you plot it, but as long as if you're plotting it horizontally, meaning that all your data will be in a horizontal manner. If it's vertically, therefore all your data will be vertically. So meaning that all your data presented will be sitting in a vertical way. So meaning that the y will represent a different stream and then the x represent the different stream on your data. So it says that a bar graph shows comparison among discrete categories. So this is where values have been certain and we do know of the values. So therefore we can actually get to use what we call a bar graph to represent discrete data. So it says one of the axis chart shows the specific category being compared and the other axis represent the measurement. And then some of the bar graph they are presented in what we call in cluster or in groups where you might find that, for example, like the one presented here. So this is what we refer as a cluster because now we are showing transportation method used on regular basis to say that in terms of bicycles, people who use bicycles, the one in blue represent the people who use bicycle for work, and the other one represent the people who use bicycle as a transportation method for leisure purpose. And this as a percentage of responded, we received the following. So from biker users, 35% of them uses it for work and 40% of them uses it for leisure purpose. And then people who use train method, we also identify that maybe 33% or 34% of them use this for work, and then 37 or 38% use this for leisure purpose. So this is a cluster. So a cluster gets to show you two different types of measurement against each other. So we get to put different types of information at once at the same time. But again, we can represent the information for people who use the same method for leisure alone, and then we do another bar graph to show for the ones for work. But instead of doing that, we can actually put that as a cluster, so which is in groups to say for bicycle in terms of leisure and work, this is the representation of information. So this information, this one can be this side. So this one is what we call a vertical graph. So if it's horizontal, all this information, the type of method used on a regular basis, transportation method, it will be sitting on the x-axis, and this will therefore come and sit on the y-axis if it's horizontally. So this information will get to change based on the type of method that you can use, whether you're using vertically or horizontally bars. And then bar graph. So in terms of the bar graph again, so the bar graph have got the main features. There are main features of a bar graph. is to say that for each and every bar graph represented, the wideness of each and every graph have to be the same from this point to this point. It should be the same from this point to this point. So this one doesn't have to be thicker than the other one. So meaning that all graphs have to have the same width of in terms of size. And then there's also have to be a space in between the previous data to the next data. So there have to be a gap. So this and this gap have to be the same on all. So meaning that if you do not get to present a gap, do not move the other one and then present a gap. So meaning that the gap in between also have to be the same. And then it continued to say that the vertical and the horizontal axis must be labeled to say that this side, what is this side measuring and what is this side measuring, to say that these are movies and these are people, to say that these are people who like the movies, the following types of movies, and these are movies that have been listed, and therefore we can actually do this different ways. If we're to perform this in a horizontal, in a vertical way, so therefore the types of movies will be sitting on the y-axis and people will be sitting on the x-axis. And therefore it says that a little should be added to the graph. A title should be added to the graph to show that what type of information is being presented within this graph. So these are the main features of a bar graph. So it doesn't have much. And then we also have got the histogram. So in terms of the histogram, so a histogram is a graphical representation of data points organized into user-specified range. So this is what caused the difference between the histo and the bar graph. If you check here, when we're measuring our bars, we're gonna use a category to say that this is comedy action. But in terms of the histogram, we use what we call a frequency. So we use frequency can only be done in numbers. So meaning that there's no frequency that is done in words. So we only have got frequency in numbers. So mostly if your data is collected and have got a frequency, so therefore it will be presented best as a histogram. So we're going to have class of those to say that if these are grade on quizzes, this will be the number of people, to say that from all the total number of students that are there within the class, those who scored between 40 and 50 are 13. Those who scored between 50 and 60 are 21. Those who scored between 70 and 80 are this much. So this is when we get to use frequency or a histogram. So histogram, it's only used when there is a frequency within our data collected. So here it says that similar in appearance to a bar graph, then the histogram condenses a data series into an easily interpreted visual by taking many data points and grouping them into logical range of bins. So we use range or frequency to say that this is the number of people that are performing a certain number of activity. So this is where we get to use the histogram. So it says that the height of each bar shown shows how many falls into that range. So for example, 40 to 50. Okay, 15 people actually managed to go to score the following marks, and then you decide what range to use. So the best use about the histogram is that you always decide what type of range to use. So you can say between 40 and 60 and calculate the average or put in the number, and you can say 60 to 80, but you need to put in a range or frequency that you do know that most people will get to understand the range that you are actually getting to use in your information. And then I believe this is the last one in terms of the histogram. So any questions?
No, sir, no questions.
So in terms of the difference between the histogram and the bar graph, how many would you point out that you could find or that you know of?
Between the histogram and the
Bar
bar
graph.
graph.
Yes.
Okay, you said the bar graph, the distance between the bars should be equal,
Yep.
right? And then the data represent the date like go histogram. Ngicela ukukhuluma ngesiZulu sir.
No, not a problem.
Okay. For histogram, say the data is actually grouped and it's used to calculate a range between izinto eziyi-2, right?
Okay.
And then good graph, what else? Yeah, that's all I can point out.
Yeah, so there are actually a lot of difference between the hist and the background. So most of those will be discussing them on lesson number 13, which I believe is after your recess or next week Tuesday. I think it's next week Tuesday, which is not before your recess or the Good Friday.
Okay.
And when is your recess?
I think it's supposed to be next week.
Okay, I will confirm as well with the academic manager. So we're gonna be talking about mostly the difference between the two, and so that when you get to present the data, either when you choose between the bar graph or histogram, you get to identify that this is the one suitable based on the difference between them. And tomorrow we also have got a mock test, which is on the 1st of April, a workshop. So under the workshop, we're gonna do a mock test, and then I will leave with the papers to actually make sure that I get to assess to see how much ready you are for the assessment, which is coming on the 14th. And then I'll give you feedback before you actually get to write.
Okay.
So please make sure that you prepare everything from lesson 1 up to lesson 9 when you come to class, because everything that we're gonna do there is gonna be related to your F1 assessment. So you're gonna be asking question after the assessment that you feel like you still need more explanation and practical example, and we're gonna treat them there in class.
No problem, sir. Thank you so much for that.
So that will be from 9 tomorrow up until 11:30 at campus room 2.
Yes, sir.
So yes, this is all in terms of today's lesson, and the next lesson, as I've already mentioned, it is the difference between the histo and the bar graphs, which we're gonna do later. So please do enjoy the rest of your weekend and make sure that you prepare for tomorrow so that you don't get to be lost during the assessment.
Yeah, okay. I will. I'll try. I'll try my best.
All right, that is it from my side for today.
Thank you, sir. Bye.
Bye.